Hello guys, welcome to another tutorial session. This is your math exam coach. If you're new to the channel, please make sure that you subscribe and hit the notifications so you get new notifications when we publish new tutorials. If you're a returning viewer, make sure you like and share with others as well. Today we're going to be looking at a speed time graph of a car journey and the type of question that we can be able to answer from there. So this is typically a kinematics question, and you will see it in both paper 1s and paper 2 at the O level stage, and at the A level you can also see similar types of questions asked in a different way. Before we jump into the question, please make sure to like, subscribe to the channel for more content. Alright, so here's what we have. So it says you have a speed time graph. The first question, we want to find the acceleration during the first 5 seconds. So this journey we can divide it into different sections. So we have the first section A, with the second section B, with third section C. As we can see here, for A, the first part, our car is definitely accelerating. All right. Then we have B here. This is a constant speed. The velocity is not changing. And C, we are in deceleration mode. So these three areas are going to be critical when we are trying to solve the question. The first part here, we want to find the acceleration during the first 5 seconds. So now we are focusing on A, the area A here. So what happens here? Our car moves from 0 to 30 in 5 seconds. So I'll quote A, the acceleration is delta V over delta T. This is similar to just calculating the gradient of this line in A, right? So what do we have here? In order for us to calculate, we need to find the coordinates here. The coordinates there are 5 and 30, right? So we know the coordinates there. We have 0, 0. So we want the change of 5, 30 from 0, 0, right? So how do we do that? So we move from 30 minus 0 divided by the change in time. It's 5 minus 0, which gives us 30 over 5. So our acceleration is equals to 6 meters per square second. So we have the answer here. That's our acceleration. Now when we come to the second part, we want to find, given the total distance of 825. So how do we find the distance in the first place? So given a speed time graph, our distance, which we call D, is going to be equal to the total area under graph. In other words, it's going to be the area of A plus B plus C. Right, so these are the three areas that we have. Area of A, which is a triangle, area of B, which is a rectangle, and area of C, which is another triangle. But we also know that this area can be represented as a trapezium. So this whole area is this is a trapezium. So this is not always the case for these time graphs. So you have to be careful. Here we can find the area of A, which is an area of a triangle, and the area of B, which is an area of a rectangle, and the area of C, which is a triangle. But in this circumstance, we know that we are dealing with a trapezium. Right. So let's go to the next slide here. So we know that our distance is equals to 825. We know that we're looking for an area of a trapezium, which is given by 1/2 A plus B times the height. Okay, so in this case, let's go back to here. We know that this distance, this is our B. So this whole thing is B, and this is A, and our height is going to be 30. So let's do that. So A is going to be the length here between 5 and 15. So A is going to be 15 minus 5, which is equals to 10. B is equals to going to be T minus 0. So this is T minus 0, which is equals to T. And our height H here is going to be from 0 to 30. So our height is going to be 30 minus 0, which is equals to 30. So what we can then now do is, with 825 is going to be half. We said A is equals to 10 plus B, which is equals to T, times our height, which is equals to 30. So if 825 is equals to 15, 10 plus T. So we can say 10 plus T is equals to 825 divided by 15, which is equals to, so here you can use your calculator to calculate this, which is 825 divided by 15, which is equals to 55. So what do we have here? So we have 10 plus T equals to 55. So we can write T equals to 55 minus 10, which is equals to 45. So we now know that the value of T here is equals to 45. So that's 45 seconds, right? So we have that. So we have solved for B, and now we want to solve for C, which is C now is asking us to compute. What is C asking us? C is asking us to find the speed. So here we want to find the average speed. Of the whole journey, right? Okay, so we know that average speed is equals to distance traveled over time. So we are given the distance. We know the distance traveled is 825. It's 825 meters. We know that the time spent now, so it's T minus 0, but we found T. So we know that time is equals to t minus 0, which is equals to 45 minus 0. So we got our time here as 45. So we can now divide the 2, which is going to be 825 divided by 45, which is going to be 18.3333, so forth. So now we can come back here and say the average speed for the whole journey is equals to 18 1/3 meters per second, like that, right? So that's how we solve this using the speed time graph. Another way to solve B would be to look at these different areas and solving. So we will look at that in a different video. Make sure to give us some feedback. Make sure to like, subscribe, and share, and put your questions in the comment section, and we'll be able to try to solve some of those questions in the next tutorial. Until next time, goodbye for now.